Hello all, this is M. Sandeep Kumar and I welcome you back to my YouTube channel Concepts of IIT Maths. So already we have uploaded 2 videos in the chapter of trigonometric ratios and this is the third video. So in the first video we have discussed about the definition of angle in standard position and different measurements of angles, like angles are measured in degrees, angles are measured in grades and angles are measured in radians. We have discussed about it in the first video, and then in second video we have solved all the problems related to the previous concept from first exercise of NCERT textbook of 11th standard. So this is our third video in this particular chapter, and here we are going to discuss about different types of angles, like what are complementary angles, supplementary angles, what are quadrant angles, coterminal angles, allied angles. So these angles are very important when it comes to this chapter or when it comes to geometry. So remember them, you have to remember them. Okay, now let us get into the video and we will discuss first about complementary angles. What are complementary angles? If the sum of two angles is 90 degrees, very simple, if the sum of two angles is 90 degrees, then those angles are complementary angles. So for example, that means if angle A comma B are complementary, then A plus B must be equal to 90 degrees. If A comma B are complementary angles, then A plus B must be equal to 90 degrees. Example, 30 degrees and 60 degrees are complementary angles because 30 degrees plus 60 degrees is 90 degrees. Another example, 1 degree and 89 degrees are complementary angles. So in this way you can create your own pair of complementary angles, and at the same time, if two angles are equal to each other and at the same time they are complementary, you can easily guess what is that pair. So it is 45 degrees comma 45 degrees. They are equal to each other and at the same time they are complementary angles. So in general, this is important to remember. So in general, dear students, in general, theta comma 90 minus theta are complementary to each other. In general, if theta is one angle, then its complementary angle is 90 minus theta. So keep this in mind. Next, let us discuss about supplementary angles. But before that, how can I see complementary angles diagrammatically or geometrically? Means very simple. Let me consider the right angle with vertex O and the rays OA and OB. So here angle AOB is 90 degrees, right? You take any one ray between OA and OB. For example, this ray. Let this ray is OC. Okay. So if this angle is theta, then automatically what is the remaining angle, dear students? 90 minus theta. You got it? So this is how you can see the complementary angles geometrically. Fine. Next, let us discuss about supplementary angles. Supplementary angles. If the sum of two angles is 180 degrees, then those two angles are supplementary angles. So when can I say that angle A comma angle B are supplementary angles? So only when A plus B is equal to 180 degrees. So you can create the pair of supplementary angles. So example, 30 degrees and 150 degrees, these two are supplementary angles for each other. Similarly, 60 degrees, 120 degrees, these two are supplementary angles of each other. And what if two angles are supplementary angles and at the same time equal angles? They are equal to each other and at the same time supplementary. That pair is 90 degrees comma 90 degrees. Right? In general, who is supplementary angle of theta? If I substitute angle A as theta, what do you get? Angle B as 180 minus theta. So in general, the supplementary angle of theta is 180 minus theta. Keep this in mind. And geometrically, where can I find supplementary angles? Let me take a straight line AB and some point O on it. So at this point, let me take another ray called OC. So if angle BOC is theta, automatically this angle is 180 minus theta, right? You have learned this in the 9th standard lines and angles chapter. So if one angle is theta, then the other angle here automatically is 180 minus theta because these two form linear pair. You should know what is linear pair already. So this is about supplementary angles. Next, quadrant angles. What are quadrant angles? For this, let me consider the coordinate axis. I'll take x-axis and y-axis which are meeting at origin. So OX is positive direction of x-axis and OX dash is negative direction of x-axis. You know it already. OY is positive direction of y-axis and OY dash is the negative direction of y-axis. Coordinate axis will divide this plane into 4 equal parts. Each part is called quadrant. So this is first quadrant, and next this is second quadrant. We are traveling anti-clockwise, okay? And then this is third quadrant and this is fourth quadrant. You know about quadrants already. You have learned it in coordinate geometry in your school time. So what are quadrant angles? First of all, assume that our initial ray OA is here and our terminal ray OB is also here. You got it? So there is no rotation between OA and OB, so which means this angle is 0 degrees, correct or not? So our terminal ray, our initial ray OA will be here itself, and for quadrant angles the terminal ray will be coinciding with either OX or OY or OX dash or OY dash. So keep this in mind. So quadrant angles are the angles where the terminal ray is either coinciding with OX or OY or OX dash or OY dash. Okay now. So initially this is angle 0 and this is angle 90 degrees. You can also take it as pi by 2. Let me use pi by 2. Next, this is 180 degrees, or we can call it as pi in radians. This is 270 degrees. This angle is 270 degrees, and we can take it as 3 pi by 2. Again come back to this angle is 2 pi. Okay now, so initially the angle was 0 degrees, next it is 90 degrees. 90 degrees means pi by 2. Next the angle is 180 degrees, that means pi. Next the angle is 270 degrees, which means 3 pi by 2. Next 2 pi, and again if you add pi by 2, what do we get? 5 pi by 2. Next again add pi by 2, you will get 6 pi by 2. 6 pi by 2 means, wait a second, 6 pi by 2 means 3 pi. Again add pi by 2, you will get 7 pi by 2. Again add pi by 2, you will get 8 pi by 2, which means 4 pi, and so on. So these angles are called quadrant angles. So what are quadrant angles here? 0 degrees or 0. Next pi by 2, pi, 3 pi by 2, 2 pi, 5 pi by 2, and so on. These angles are called as quadrant angles. Next, let us discuss about coterminal angles. What are coterminal angles? First of all, two angles are said to be coterminal angles. Again, two angles are said to be coterminal angles if the terminal ray of both angles coincide. This definition is very important. I wrote the definition here. So two angles are coterminal angles if the terminal ray coincide, but remember those two angles must be angles in standard position. Okay, to understand this, let me consider an angle here on the board whose initial side is OA and terminal side is OB, and let this angle is, for example, 30 degrees. I'm just taking an example. So this angle is 30 degrees, right? So where I have measured it clockwise direction, anti-clockwise direction. What if I measure the same angle clockwise? I told you, if we are measuring an angle clockwise, then the angle is considered as negative. So if this part is 30 degrees, then the remaining part will be 330 degrees with negative sign. So please observe, dear students, OB is the terminal ray of 30 degrees, and at the same time OB is the terminal ray of minus 330 degrees also. So therefore I can say that 30 degrees comma minus 330 degrees share the same terminal side, and therefore those two angles are called as coterminal angles. Co means same, terminal. Coterminal angles means two angles which have same terminal side, but remember both the angles 30 degrees and minus 330 degrees must be in standard position. Angles in standard position means I told you already, the vertex of angle is coinciding with origin and the initial ray coincides with positive direction of x-axis. Like this, for 30 degrees, don't assume that there is only one coterminal pair. If you add 360 degrees, for 30 degrees, what do we get? 390 degrees. Even 30 degrees and 390 degrees share the same terminal side. Look at the figure here. So this is 30 degrees, right? So this is 30 degrees. Now 30 plus 360. 30 plus 360 is equal to 390. So this angle 390 degrees also has the same terminal side OB. Correct or not? For 30 degrees the terminal side is OB. For 30 degrees the terminal side is OB. For 360 degrees, 390 also the terminal side is OB. So therefore 30 and 390 degrees are also coterminal angles. In general, if theta is a coterminal angle, can you guess what is its coterminal angle in general? If theta is one angle, what is its coterminal angle? Remember this. In general, dear students, if theta is one angle, its coterminal angle is 2n pi plus theta. What is n means? N can be any integer. If I substitute n value as 1, what I will get? Theta comma 2 pi plus theta. Yes, these two are coterminal angles. If I take n value as minus 1, then what happens? Then I will get theta comma minus 2 pi plus theta. Yes, these two are also coterminal angles. If I take n is equal to 100, then what I will get? Theta comma 200 pi plus theta. These two are also coterminal angles. So in general, theta comma 2n pi plus theta, this pair are always coterminal angles. And remember one more thing, every angle has infinite other coterminal angles. For 30 degrees, how many other angles are sharing same terminal side? How many other angles are coterminal angles for 30 degrees means there are infinite angles. Okay na? So as I have given already, 30 degrees comma 390 degrees, these two are coterminal angles. Add 360 for this angle. Add 360 for this angle, what do you get? 750 degrees, right? Again 30 degrees comma 750 degrees are coterminal angles, and this goes and so on. So I hope you understood the meaning of coterminal angles. Next, let us discuss the most important concept among the angles, allied angles. The definition of allied angles. If the sum or difference of any two angles is a multiple of pi by 2, or the sum or difference can also be equal to 0 degrees. So take those two angles, you add them or you subtract them. The result must be a multiple of pi by 2 or the result must be 0 degrees. So in that case, those two angles are said to be allied angles. To understand it better, let me consider two angles A comma B. Either A plus B should be a multiple of pi by 2. N pi by 2 means n is an integer, where n is an integer. You can get 1 pi by 2, 2 pi by 2, 3 pi by 2, 4 pi by 2, or 0, or minus 1 pi by 2, minus 2 pi by 2, minus 3 pi by 2, like that. So if I take two angles, either the sum of them must be a multiple of pi by 2 or the difference must be a multiple of pi by 2. It can be equal to 0 also. If you take n value as 0, you will get 0 only, right? So either sum must be a multiple of 90 degrees or the difference must be a multiple of 90 degrees. If that is the case, those two angles A and B are called as what angles? Allied angles. So now example. Let us consider 30 degrees and 120 degrees. Observe one thing. 30 degrees and 120 degrees is there. Obviously, if you add them, you will get 150 degrees. But 150 degrees is not a multiple of pi by 2. 150 degrees is not a multiple of 90 degrees. Correct or not? But the difference between them, what is the difference between them? 120 minus 30 is 90 degrees. So the difference of 120 and 30 is 90 degrees. It is a multiple of 90 degrees. Therefore, 30 degrees and 120 degrees are allied angles. See, either sum must be multiple of 90 or the difference must be multiple of 90. Keep this in mind. Similarly, take another example. 35 degrees and 245 degrees. No, 35 degrees and 235 degrees. These two are allied angles. Why 35 degrees and 235 degrees are allied angles? Because in this case, what is the sum of these two angles? 235 degrees plus 35 degrees is equal to 270 degrees. 270 degrees is 390, sir. Clearly, the sum of these two angles is a multiple of 90 degrees, right? So therefore, 35 degrees and 235 degrees are also called as allied angles. So in this way, you can create your own examples. Now in general, which two angles are allied angles? This is most important. Listen carefully. In general, any two angles among the following are allied angles. So what are those angles means? Plus or minus theta, 90 degrees plus or minus theta, 180 degrees plus or minus theta, 270 degrees plus or minus theta, 360 degrees plus or minus theta, 450 degrees plus or minus theta, and so on. So among these angles, you can take any two angles. Those two angles will be allied angles, certainly. So for example, let me take 90 minus theta and 360 plus theta. So I have taken 90 minus theta and 360 plus theta. Look at these two angles. These two angles are allied angles. Do you know why? Because if I add these two, minus theta and plus theta will get cancelled, and what do you get? 450 degrees. 450 degrees means 5 times 90. So if I add these two angles, the sum of these two angles is a multiple of 90 degrees. Therefore, 90 minus theta and 360 degrees plus theta are what angles? Allied angles. Like this, you can take any two angles out of these angles. They will be allied angles. If you want another example, let me take 180 minus theta and 450 degrees minus theta. In this case, if you add them, what do you get? Certainly you will not get a multiple of 90. Instead of adding, then what we have to do? Let me subtract and check. Let me find the difference. So find the larger angle minus smaller angle. 450 minus theta minus of 180 minus theta. So 450 minus 180. So what is 450 minus 180? 270 degrees. And minus theta, minus into minus theta. That means minus theta plus theta will get cancelled. The result is 270 degrees, which is 3 times 90. So therefore, the difference of these two angles is odd multiple of 90 degrees. And hence, those two angles are what angles? Allied angles. So therefore, dear students, the sum or difference of any two angles, if it is multiple of pi by 2, then those angles are called as allied angles. Now let us find allied angles on the coordinate axis. Their location on the coordinate axis is very important for our understanding of trigonometric ratios. Okay, let us locate the allied angles on the coordinate axis. So we have considered our coordinate axis, and this is our first quadrant, second quadrant, third quadrant, fourth quadrant. Okay, so let me take an angle in standard position. So its initial ray OA coinciding with positive direction of x-axis, and its terminal ray is moving. Keep this in mind. And let us consider our quadrant angles: 0 degrees, 90 degrees, 180 degrees, 270 degrees, 360 degrees, and again 450, 540, 630, 720, and so on. Okay, now initially this is our terminal ray coinciding with initial ray. If this terminal ray is present in first quadrant, let us see what happens. See, the terminal ray has been rotated through an acute angle theta, correct or not? Let theta be an acute angle. The terminal ray is rotated through an angle theta. Now it is in first quadrant, right? Then this angle theta is an angle which is in first quadrant because theta is acute, and at the same time Assume that you are here. So from here you are coming back. You are coming back means you are rotating clockwise. When you are rotating clockwise, instead of taking plus theta, we will take minus theta. Correct or not? From 90 degrees, you are coming back through an angle theta. Since you are traveling in clockwise direction, 90 degrees minus theta. 90 degrees minus theta is also an angle in first quadrant. Therefore, the two angles theta comma 90 minus theta are angles in first quadrant. Keep this in mind. The allied angles theta and 90 degrees minus theta are angles in first quadrant. Similarly, we are at 90 degrees. So if I travel anti-clockwise from 90 degrees plus theta, correct or not? I am traveling anti-clockwise 90 degrees plus theta. Then 90 degrees plus theta is an angle in second quadrant. Come to 180 degrees, and if I travel clockwise, I am going back. Okay na? So 180 degrees and I am going back means 180 degrees minus theta. Then 180 degrees minus theta is an angle in second quadrant. Now again I am at 180 degrees. So if I travel front means anti-clockwise, back means clockwise. Okay, I am at 180 degrees, and if I travel front, then 180 degrees plus theta is an angle in third quadrant. Now I am at 270 degrees, and if I travel back, okay na, then 270 degrees minus theta, so which is an angle in third quadrant. Now I am at 270 degrees. So if I travel front, then we get 270 plus theta, which is an angle in fourth quadrant. Now I am at 360 degrees, you got it, and I am traveling back. Then 360 degrees minus theta is an angle in fourth quadrant. And at the same time, assume that you are at 0 degrees. Instead of calling it 360 degrees, assume that you are at 0 degrees. And if you travel back, then it is minus theta, correct or not? Even minus theta is also an angle in fourth quadrant, where theta is an acute angle. Keep this in mind. In all these cases, theta is an acute angle. Now look at this. What are these angles? Theta minus theta, 90 minus theta, 90 plus theta, 180 minus theta, 180 plus theta, 270 minus theta, 270 plus theta, 360 minus theta. What are these angles? These are allied angles, and these angles have their positions in different quadrants. This is very, very important to know. To understand trigonometric ratios and their behaviors, you should know where are these allied angles. I hope it's very clear for you. Okay, I'll keep revising it while solving the problems. So remember that theta and 90 minus theta are first quadrant angles. 90 plus theta and 180 minus theta are second quadrant angles. These two are third quadrant angles. These two are fourth quadrant angles. And assume that you are at 360 degrees. If you travel front, 360 plus theta. So 360 plus theta is again first quadrant angle. Now this is after 360 degrees. If you add 90, you will get 450 degrees, right? 450 minus theta, first quadrant. 450 plus theta, second quadrant, and so on. So I hope you understood this. These are quadrant angles, and you should know where is 90 plus theta in which quadrant, 180 minus theta which quadrant, 180 plus theta which quadrant. These are very, very important. So this is how we can locate allied angles. So in the next video, we will discuss about different trigonometric ratios and the signs of trigonometric ratios in different quadrants, and remaining topics and remaining concepts related to trigonometric ratios. Okay, so that's it in today's video, dear students. So we have discussed about complementary angles, supplementary angles, coterminal angles, and allied angles in today's video. I hope you understood the concept and you felt that it's important, it's useful. So if you have felt that it is very useful for you, do like the video. So give your feedback, valuable feedback in the comment section, and share it to your friends if you feel it valuable. And don't forget to subscribe if you are new to this channel. Thank you, dear students. We'll meet in next video.